Hello everyone, this is Mahmoud Ali Khan and I'll be walking you guys through a project that I did on credit score classification. So let me start off by explaining what exactly is happening in this code block and then we'll proceed further accordingly. So this is the read CSV file function and this function basically reads the data in my data set using Python CSV module as instructed by the professor, and it ensures that I can process the data effectively. And I've also added a try and accept to block to debug any errors. Okay. So yeah, this function will successfully load my data. And then moving on to the next code block, this is the create database function. This is responsible for setting up the SQLite database. So we connect to a database named credit score. And if the database doesn't exist, SQLite will create one for us. And then uh, we create three tables: customers, credit details, and loan details. And each table will have a specific information. Like for example, customer will have information about the customer ID, customer's name, age, and etc. Credit details will have details about the customer's credit score, uh, payments, and all that stuff. And similarly, the loan details table will have the details about loans, EMIs, and all that. Okay, so then moving on to the next one, populate database. Here, this function inserts the data from the CSV file into our SQLite database. And here we are looping through each row in the data and extracting relevant fields. And then next one, yeah, check database. This function helps us verify that the data was inserted correctly. And then fetch data. Here we like this function demonstrates how we fetch and combine data from multiple tables. Like it joins the customer's credit details and loan details, the tables that we previously created. It joins these to produce a more comprehensive data set that includes all the customer details, credit scores, loan information, and stuff, all the details basically. And then yeah, converting the data into pandas data frame as instructed. And here starts the data cleaning and pre-processing. So what I've done is renamed renamed a few columns to make it to work easy, get our data set to work with us easier. And then I've renamed the index. I've dropped irrelevant columns, and I've split one column into two. All this so that we can perform better with the data set. See, here's the combining two columns into one, removing non-data rows, removed repeated rows for duplicate rows, and then I standardized strings, stripping white space or converting to lowercase. Okay, so moving on to the next one. Uh, so here's our Y data profiling. Yeah, here I tested and split the model here, and this is what the results I got. You can see here. So moving on to the Y data profiling. So we first select a subset of columns that are most relevant for our analysis. Okay, such as like, see, these are the most relevant for us, and so we only select these ones. And if any of these selected columns are missing, a warning will be printed for us. Uh, This report is served as an HTML file named credit score EDA subset, which we can open in a browser for detailed explanation. So yeah, now moving on to this is the correlation matrix. Uh, this function calculates a pairwise correlation between the numerical features. Okay, and it helps us understand the relationships in the data. And then here I've created a missing values heat map. First, we use the isNull function. To create this, we use an isNull function to calculate the total number of missing values in each column. And then after running all this, this is what we get. And this is the summary that we get over here, all this. And And then comes feature observations. Here I'm checking basic statistics for numerical columns, and then we check for skewness in numerical columns. And yeah, here in this code block, we are detecting and treating outliers. I've written a code for that so that we can visualize outliers for each numerical column using box plots. And these are the box plots I generated. And by examining these visualizations, we can detect whether to cap extreme values, transform the data, or handle outliers in any other way. So yeah, then moving on, yeah, here starts our ML flow. Experiment tracking. We load each experiment, the results of each experiment into this ML flow tracking URI. And when you click on this, you will be able to see my DAG sub. For example, where is it? Okay, this is the Streamlit API. Okay, anyway, so yeah, yeah, okay, here it is. So these are all the experiments, and these are all the results. So when you click on these, you'll be able to see what I've done. Yeah, so we start off by the first experiment, and then we keep moving on further and further, and each experiment's results will be loaded into the DAGs hub profile. You see when we run this code, here comes the DAGs hub link, and we automatically load it into the DAGs hub repository. And then comes experiment 2, and uh, here you can see that I've set up a DAGs hub token and tracking URI. And here I'm configuring the ML flow. I'm testing ML flow connection, and here again I'm loading the dataset and replacing it with our actual dataset path. And I'm here I'm removing all leading or trailing spaces, if any. And then we move on. Yeah, we do this for each experiment. uh, we do this for each experiment. You can see here, here starts another ML flow experiment, and this is the hyperparameter tuning grid for each model. Logistic regression ridge, random forest, XGB classifier, and we set up grid search for that. We train the model using grid search, and we log the best parameters. We determine the best parameters using a few metrics. Most important metrics are F1 score and confusion matrix, obviously. And here are our cross-validation results. And again, all these are loaded into the DAGSUB website, DAGSUB repository. And we do the same for experiment 3 as well. Uh, we are testing ML flow connection. We are loading the data set. We perform feature engineering in this experiment. We handle any missing values if and impute missing values with mean for numerical columns. This is what the experiment asked us to do. And then yeah, we split the data into features and target. Here we again train, test, and split it. We are defining a pre-processing pipeline. Here we are creating a pipeline, and these are again the models that are supposed to be trained. We start ML flow experiment to feature engineering and model training. And again, the results are loaded into the DAG repository. Moving on, this is experiment 4. We do the same. Set up DAG token, test it, get the results, and again load it into the DAG repository. Same for experiment 5, 6, and 7 as well. And yeah, so let me just quickly move forward because I barely have time on the video. So yeah, we do the same for experiment 5, 6, and 7 as well. And yeah, yeah. So here, uh, this is where experiments 7 ended. And here we are creating a list to store all the F1 scores and determining the best model. And here we are saving our final model using joblib. So this is the code for that. And then we move on. We move on to this code. This is for this as the code I've written to create the fast API app. And so we have here save the final model using joblib, right? And here we are creating a fast API app to serve that model. And then we containerize this model, uh, uh, containerize this fast API application using Docker, and we then push it into Docker Hub. You can see here I've pushed my model here. This is my model, and then yeah. So and then and we also loaded this into a cloud platform. I've used Heroku for that. And you can see here I've also got the results. Credit score prediction API is running. So which means that our deployed model is successfully loaded and is running. And then this is the code I've written for creating a Streamlit application. And this Streamlit application is basically created so that it can interact with our deployed model. You can see here, this is the Streamlit app that I've created. And if I click predict here, it predicts for classification is 0 because I've not entered values. If you change the values, it will correct the it will predict the exact value. So yeah. And then so yeah, this is my GitHub repository. And here is my website. This is the Jupyter book website that was asked to be created. And here I've loaded all the links. This is the link for my GitHub repository. And yeah, this is the link for the Streamlit app that I just showed. This is the deployed model. These are the all the this link will have all the experiment results that are loaded into into DAG sub repository. And this is the Docker Hub container that I just showed. And this is the resume that I attached. So yeah, that's basically it. Uh, that was my project in Python for this semester. So thank you.